So hello everyone, welcome to the Sasensei International Dojo. We're happy to welcome Richanne, who's going to talk to us about variable information functions. Over to you.
Okay, so I'm Richanne Watson. I've been programming since 1996. I got introduced into SAS at school. And then for my first project as an intern, I was given a program, a SAS manual, like version 5, and said, figure it out, you're now responsible. So that was my introduction into SAS. And so after that, and having to do all that research, I just started falling in love with SAS even more. And then just every time I come up across a new problem, I want to research it to figure out a better way to do it. So we're going to start talking about variable information functions. Typically, there's a situation, at least in my industry, where there is a need to update the variable information, things like the attributes. And we have to get that information somehow. So in order to do that, we have to get some further processing. Most of the time, at least in the past, I always used PROC contents. That was my go-to to get the information that I needed in order to make updates to the data sets. Or I would do a manual update. But there has to be a better way. And so I started doing some investigation, and this is where I came across the V functions. And this was years ago when I came across them. But this helped with a more tangible solution that got rid of a lot of the manual work that I was having to do. So just a real quick refresher, there's different ways to obtain this information, this metadata. So every variable has information other than just the value. So there's information that's sitting behind there, such as the label, the length, and the formats. Okay, as I mentioned earlier, the typical way to get this information was using PROC contents or the PROC data sets. And so this is going to have all of this information, and you can retrieve it and store it as a SAS data set that then you can further use it as processing in a future step. Similar information can be retrieved from dictionary.columns or the SAS Help B columns. These approaches are done as standalone processors. So in other words, they're outside of the data set. So you'll have to do a separate step and then come back into your data set to bring that information in and then do your processing. All of these forms of metadata are immediately accessible upon the start of your SAS session. So regardless of the type of SAS session you have, whether it's EG, Studio, or Display Manager, it's available. You can also access this metadata when you do a batch submit. So with our V functions, it utilizes the same metadata that is going to be used for the dictionary tables. And you can use it to retrieve the variable attributes as the labels, formats, and length. You can also determine whether it's an array. You can simplify the processing time to use to coding and retrieving the necessary variable information, especially for repetitive data. So if you're doing something that's repetitive, this is going to be beneficial in helping to speed up the time and processing steps. You can do the retrieve the information from within the data set. So there is no need to do a secondary process to go outside of the data step and retrieve that information and then bring it back in. It's all done within the data step. And it can help make your program data dependent versus having to do user dependence or manual updatings. So these are the various V functions. The V functions start with the letter V, which is why I refer to them as the V functions. They're called variable information functions. And the rest of the characters pretty much describes what the function is assessing. For example, VName takes the argument and returns the name of the variable. VLabel returns the label of the variable. And so basically it's straightforward in terms of what that function is doing. For each of the V functions, there is a corresponding V function that ends with the letter X, which is that little statement at the bottom. And the difference between the two is that for the ones that end in a letter X, it is assessing an expression, and that expression is going to be used to basically create a variable. And we'll actually show an example of this. The ones that do not end in an X either take a variable name or an array element. So we're going to actually walk through 3 different examples just to illustrate the use of these functions. The first one is setting missing numeric code to have missing data to have missing numeric codes. The second one is we want to rename all of the variables to have a suffix or a prefix. And the third one is we're looking for specific variables. Coding missing data, example 1. we want to code all of our numeric missing data to have numeric missing codes. And we typically use if then else to assign each of these individually. So we would have to know the name of every single variable, know what type of data was being stored in that variable, and then use a series of if then else. And these are the missing codes that we want to actually assign. So if it's a float, we want to use the .d, date time is a .t, date is a .m, and time is a .h, and then everything else, regardless of the type of numeric value, it's going to be a .z. So again, we would typically use if then else, knowing every variable. If it's variable x, then it's going to be equal to underscore x. That way we know, sorry, not underscore x. Variable x would be equal to variable x .d if it's a decimal. But how do we do all of this without knowing what the variables are, what those variable names are, and what those formats are for those data set, those variables? The easiest way to do this, at least for me it was allowing for a generic array. We're just going to read in all of our numeric variables for that data set. And we're going to just grab everything that's numeric, which is why we're using the underscore numeric underscore. And then we're going to just start looping through each numeric variable identified in the array and process all the variables that had a missing value. And so we're making sure that we're only looking for the ones with the missing value because those are the only ones we're concerned with. After we found those variables, we're going to then start processing it using the v functions. So we're going to look at v format d to see if there is a decimal in the format. So it's going to look at that format that's sitting back there behind it. Look at the metadata and say, is this associated with a, like an 8.1 or an 8.2? And if it does indicate that there is a decimal, it's going to assign it a .d. It then looks at v format to see if there is a date time format attached to it. And if it is, it assigns it the .t. If it's just the date format, it's a .m. If it's a time format, and it's a .h. Otherwise, everything is just going to get set to a .z. With this approach, I didn't need to know the variables in the data set. I didn't need to know any of the information that sits behind those variables before processing this. I was then able to put this into a loop so that I could go through every data set within that library. And I didn't need to know any other information other than I just needed to set those numeric missing codes. So this is what our data set looked like to begin with. And after processing the program, I was then able to add in all of my missing codes so that I could easily identify that this is a other variable. This one, the def dt, is just a strictly date variable, and the def tm is a strictly time variable. The other example is to rename all of our variables. And so we want to rename our variables in the data set to have an underscore. So this is a little more complex example. And we want to have our data have a prefix. And so we want to have this prefix of an underscore. So you may ask why we would want to do something like this. I actually do this quite often, and it's because we need to reassign attributes based on a set of specifications, or sometimes I want to do some calculations on a number of variables and create a bunch of new variables that I'm going to be using for my actual output. And I don't like to keep a bunch of junk data or junk variables in my final data set. So by renaming everything, instead of trying to remember what the calculated variables were, because sometimes the programs can get pretty long, it's easier for me just to do a drop equal underscore colon, and it drops all of my variables that were renamed temporarily so that I can have my calculated variables. So that's the approach that I've taken, but mainly I use it for just trying to reassign attributes because we have to have them meet our actual specifications according to the FDA guidelines. So this is a quick approach that I've taken in terms, I have to do this multiple times with a lot of different data sets. And so being able to rename things or basically change the values manually was very tedious and time consuming, and it was prone to typos. And at least with this way, I was able to rename variables quickly. So I used the SAS help fish data set as my example. So I created two macro variables. One contains all the characters and one contains all of the numerics. The same approach can be done for the entire data library structure so that you can loop through all the data sets within the library. So this is what I ended up with. I ended up with two macro variables, one for the characters, which is the species, and one for the numerics, which was the weight and the length and the height and the width. And I had the prefix of the underscore appended onto them. So in the previous slide, we added the underscore to both the characters and the numerics. And so in an array processing, I have two different arrays, one for characters and one for numerics. And we're going to process these individually. We want the variables, the new variables, to have the same data type that was used for the old variables. And so what I went through is I created two loops, one for characters and one for numerics. And they're basically going to have a similar structure in terms of how they're going to be running through. So we're just going to loop through them. And we don't need to know the number of data sets we're processing because it's going to loop through them, but we also don't need to know the number of variables within those data sets because it's just going to have that generic element of the asterisk to start looping through all of the different characters and numeric variables. So let's just walk through how this is processing it. So the v value x is going to actually process. And recall I mentioned that any of the v functions that end with an x requires an expression. And so this is an actual expression, substring of vname, the array element 1 or I, and we're going to substring that. So that's an actual expression. That expression is going to evaluate down into an actual variable. So, but we're going to work from the inside out. So we actually need to resolve what vname is, figure out what vname is resolving to. And so if we let I equal 1, species is our first element. And so it's going to return underscore species. That is what vname is returning. Our expression was we're going to substring that returned value by starting at the second character. And then now we're going to retrieve the value for species. And so that's how I was able to set underscore species equal to species and loop through all of the variables in that data set without knowing what those variables were. And I did it again for the numeric counterpoints. So this was the original data set. And then now I just changed all of the variable names to have that prefix on them. Another one is we want to look for specific variables within a data set. So in the SAS.help data set, there's a bunch of, there's about 5 data sets that have CITI, that start with the word CITI. And I want to grab all the information that is indicating that it's a billable field. And I want to sum up those billable fields. How do I do that without knowing what these are? Because what's happening is when I was looking at the data set, there was, like I said, 5 data sets and they all had different variable names. And so I was trying to figure out a quick way to do this. And so what we're going to do is we're going to look for any of the labels that have the word BIL in it to indicate that it's billable. So this is just an example of one of the CITI data sets. As I mentioned, there are 5 of them and the variables across the 5 data sets are not consistent. And so we have to go either know all of those variable names or we have to examine it. And so in real life, we know that the data that we typically get in is not always going to be consistent in terms of variable naming structures or conventions. And so we want to find a quick and easy way to figure out how to grab the variables we need without knowing what all that information is. And so we want basically SAS to examine this metadata that's sitting behind each of these variables and extract it for us. And so basically this is the program I created. I am bringing in all of the CITI data sets. Just for sake of illustration, I only brought in the first observation for each of the data sets. I created a source variable to show that what data set it was originally coming from. And then now I'm going to start summing up all of the billable variables. And so I'm looping through all of these numeric values because we know that the billable variables are going to be numeric. But when I started doing that, I noticed that there was a variable that had the label automobile, which of course has VIL in it. So I had to make sure I excluded those as well. But I used the VLabel function to actually look at all of the labels associated with all of those variables to retrieve that information. And so this is my final data set. I had a source variable that indicated what source the data was coming from. And the first record, this was the values of all of the billable variables summed. In conclusion, the V functions can help remove the manual process. It makes it more data dependent versus user dependent. It helps eliminate the potential mistakes by relying on that variable information for input versus the user input. And it can help with the minimizing of coding that is for repetitive tasks. So if you know that something's going to have be done repeatedly, but the data sets aren't always consistent or the variables aren't always consistent, you can rely on these functions to bring in that information to figure out what kind of processing needs to be done. And it's a tremendous help when trying to implement something across, like I said, multiple studies and or data sets. So when we're trying to look at data that's going to be processed in certain ways, then we can just implement these functions to actually start looking at this metadata sitting behind the variables to figure out how to process this data. And this is the various ways to contact me. And now that I'm part of the WhatsApp for Sensei, you can contact me that way too. Any questions?
Thanks, Vishan. That was great. I'm just checking the chat. No questions so far.
I just have one comment because I've been playing a little bit with these V functions. There is one thing SAS is missing about those functions. They are not available in where statement.
Oh, they're not available on a where statement.
Yeah, when you try to like extract the data and use, for example, v-value with the formatted version of the variable, you can't do it with where. You have to do it either with if, subsetting if, or some other way. You cannot put them inside the where clause. So that,
okay.
Yeah, that's the only thing that SAS is missing about those functions, because they are very, very, very useful one, exactly as you described us, but you cannot use them with where clause.
Yeah, I got introduced to them when I was actually working on a client that it was a food-based client, and we were trying to figure out how many changes people were making to specific items, but they wanted to exclude all of the bread options. But the thing is that the data was changing monthly. So I never knew what bread they were going to have for a specific month. And so I was like, there's got to be a way to extract that in my processing. And that's when I found the V functions.
Peter Crawford asks if there's anything in the V functions that lets you modify the dataset header.
I don't think so. I mean, because these are for variables, and the data set header is labels associated with the actual data set name. I would think that you would have to use a PROC data sets to actually do that. Or you can actually just do it within on the data set. If you're referring to the label in the data set, I would just do it when you do the data, like data source or data X, and then you just do label equal.
In the data statement, okay.
Yeah, on the data statement. And that's how typically we do it in the clinical industry, because all of our data sets have to have labels, and so we just use the label equal.
There are user-defined spots. There are user metadata you can stick in a dataset header. This was introduced in SAS 9 or some time ago, anyway. But I don't see any V functions to pull that information out. Are you aware of it?
I've never pulled header information out with a V function. I've always just used like PROC data sets or PROC contents. But
yeah, that's a good point. There's
dynamic access was the objective. Dynamic access.
Yeah.
Extended attributes is something worth mentioning as well. So I know in SQL Server you have these extended properties. There's something similar in datasets that you can set any attribute you want.
Yep.
Okay. So unless there's anything else, I'll stop the video and say a big thank you to Richanne. Contact details on the screen. Thanks very much.
Thank you.